On this last one, I want to start with the graph. We can see in green the graph of the rational function, where we've got the quantity x cubed plus 1 over x minus 1. And it is shown in green. We've got one branch of this, so to speak, over here, left of x equals 1. Clearly, x not equal to 1 for the domain, and it's going to create the vertical asymptote, x equals 1. And then we have another branch up here. It seems like over on the left, it's following this parabola, and over on the right about here, is starting to look more and more like the dashed red parabola. If I zoom out far enough, you can barely tell the difference. So how would we have known? That was how things would appear. Well, I've already mentioned the domain. There it is in Sepp-Weller notation. We can actually factor the numerator. -1 cubed is -1, and -1 plus 1 is 0. So we're missing an x squared, we're missing x to the first. The numerator is equal to x plus 1 times the quantity x squared minus x plus 1. Neither of those is exactly the same as the only factor in the denominator. Now, what else here? X squared minus x plus 1 has complex zeros. I have to use long division. Let me write that a little further down. Synthetic division, the way we've learned it, only covers dividing by linear factors. I'm not dividing by x plus 1. That was to factor the numerator. Up 0x. And then plus 1. Dividing by the x minus 1. X cubed divided by x to the first is x squared. And we'll multiply that to the entire divisor. We subtract this. So that's going to lead to adding the negatives of those. A minus b is equal to a plus negative b. So x plus negative x cubed cancels out. 0x squared plus x squared is x squared. Bring down the rest. Begin a second round. X squared divided by x to the first is x to the first. So we're going to distribute that to the entire divisor and subtract x squared minus x. It's going to change our signs. So now we have x squared plus a negative x squared canceling out. 0x plus a 1x. Bring down the 1. And I better put the divisor that we got there. Well, not divisor, but quotient. That was x to the first. So put that above its like term. And then a third step of division. X divided by x is 1. When I multiply the divisor by 1, I've got x minus 1. But I change those signs. X plus a negative x cancels out, and 1 plus 1 is 2. So that's telling us that g of x could also be written as x squared plus x plus 1 plus our remainder of 2 over the divisor x minus 1. And as the absolute value of x gets large, so will the absolute value of x minus 1. 2 divided by that, as that's getting larger, this is going to be heading off towards 0 as x is approaching positive or negative infinity. And so we get an oblique asymptote with the equation y equals x squared plus x plus 1. Now we should also look for x and y intercepts. If we put in 0, we'll have 1 over negative 1. So 0 comma negative 1 is the y-intercept. Looking at the factored version, you should double check that this will only give you complex solutions. We get an x-intercept of negative 1 comma 0. And the only other special value of x besides negative 1 that we found was the 1. X equals 1 gives us our vertical asymptote. Now we already know what happens in between. When x is 0, y is equal to negative 1. As x is equal to 1, it's undefined. And when x equals negative 1, we get a 0 of the numerator. It's giving us an x-intercept. So I want to see what's happening, since we already know what's happening in between the two special values of x, see what's happening to the left and to the right of it. So let's see here, x plus 1. Well, before factoring is easier to deal with on this one. G of x equals x cubed plus 1 over x minus 1. So g of positive 2 would be 8 plus 1, that quantity, over 1. Whereas when we put in negative 2, it's going to be negative 8 plus 1 over negative 2 minus 1. So negative 7 over negative 3, the negatives will cancel. All right, take a moment to take in, we're plotting negative 2 comma 7/3, negative 1, 0, 0, negative 1, and 2, 9. And we will also show a dashed line for the vertical asymptote x equals 1, and a dashed parabola for y equals x squared plus x plus 1. Since the multiplicity of the -1, which is the 0 of the numerator, is 1, and the multiplicity of x equals 1, the 0 of the denominator, is 1. Those are both odd. So we're seeing a change in signs crossing the x-axis at the x-intercept, and a change in signs of the y-coordinates to either side close by the vertical asymptote. So there's the 4 points. Include that vertical asymptote. Okay, so we're seeing that change in signs crossing the x-axis. We're seeing the change in signs in the y-coordinates to either side of the vertical asymptote. We put in the parabola as well. We should expect to see this over to the far right. We'll see our curve acting more and more like the parabola over here. Down here, it's moving closer towards, as x approaches 1 from the left, then y is going to approach negative infinity. On the right, what we're going to see as we go to the far right, the curve is going to get closer and closer to the parabola, whereas since it cannot cross the vertical asymptote, it's going to be trapped up there. So it's going to have to go towards positive infinity as x approaches 1 from the left. Y will have to approach positive infinity. So there it is in green again. And there we have it. I hope these have helped. If so, please like the videos, subscribe to the channel, and if you know of anybody else working on similar material, they need some extra help, pass these on their way. I'll see you in the next one. Take care.